Welcome to Fuzzy Mathematics, the Basics. This is the second lecture, Lecture 2. In this lecture, we will talk about crisp sets and their characteristic functions, fuzzy sets and their membership functions. We are not familiar with fuzzy sets, but we are familiar with crisp sets. Let's record crisp sets and their characteristic functions. Let X be the universal set. The polar set of X is the set of all subsets of the universal set X, which is denoted by this notation. Let A be a set. For each element X, either X is in A or X is not in A, excluding the middle. It must be either this or that. In order to generalize the crisp set to the fuzzy case, we will consider the degree of membership for each element X to a particular set A. The membership for each element X in set A is either non-membership or full membership. The degree of membership of X in set A is either 0 or 1. Therefore, we can define a function from the universal set X to the set with two elements, 0 and 1. The characteristic function chi sub A maps the universal set to the set 0 and 1. The domain of this function is X, and the range is the set 0 and 1. For each element X in the universal set, the image of X is chi sub A of X. Chi sub A of X equals 1 if X is in set A. Chi sub A of X equals 0 if X is not in set A. The function chi sub A is called the characteristic function of set A. For each element X in the universal set, chi sub A of X indicates the degree of membership of X in set A. If chi sub A of X is 1, it means the degree of membership of X in set A is 100%. It belongs to set A. If chi sub A of X is 0, it means the degree of membership of X in set A is 0%. It does not belong to set A. Next, let's approach the subject from a different direction. Given a function f, where its domain is the universal set X, and its range is the set 0 and 1, can you find a crisp set such that the given function f is exactly the characteristic function of the crisp set? The answer is yes. In fact, let A be the set of the elements such that f of X equals 1. Then the characteristic function of the crisp set A is the given function f. On the one hand, for each crisp set, it has a unique characteristic function. On the other hand, for each function, where its domain is the universal set X, and its range is the set 0 and 1, there exists a unique crisp set such that the given function is exactly the characteristic function of the crisp set. So, if we can generalize the definition of the characteristic function to the fuzzy cases, then we can generalize crisp sets to fuzzy sets. How to do that? Thinking of the example of old people, in the fuzzy cases, some elements have partial membership. So, we will just extend the range of the characteristic function from the set 0 and 1 to the closed interval from 0 to 1. Now let's look at the definition of fuzzy sets and their membership functions. Let X be the universal set. Our fuzzy set A in X is characterized by a membership function mu sub a from the universal set X to the closed interval from 0 to 1, which associates each element X with a real number in the closed interval from 0 to 1, where the value mu sub a of X represents the degree of membership of X in A. The function mu sub a is called the membership function of A. A fuzzy set is also called a fuzzy subset. This definition was given in a paper by Professor Zadi in 1965. The fuzzy power set of X is the set of fuzzy sets in X, which is denoted by this notation. Intuitively, a fuzzy set is a set without sharply defined boundaries, that is, a set in which an element may have partial membership between full membership and non-membership. Suppose A is a fuzzy set. Mu sub a is the membership function of A. The nearer the value of mu sub a of X to 1, the higher the degree of membership of X in A. The nearer the value of mu sub a of X to 0, the lower the degree of membership of X in A. If the membership function of a fuzzy set can only take two values, 0 and 1, then the membership function degenerates to the characteristic function. Crisp sets are special cases of fuzzy sets. Fuzzy sets can be used to model the linguistic fuzziness existing in words, such as young, old, cold, hot, and so on. Let's look at some examples. First, example 1. In this example, we will consider the word young in the context young people. Let X be the set of all possible numbers of one's age. Say the closed interval from 0 to 150. Let Y be the fuzzy set young, and its membership function is defined as follows. The degree of membership of X in Y equals 1 if X is greater than or equal to 0 and less than or equal to 25. And the degree of membership of X in Y equals the reciprocal of the quantity 1 plus X minus 25 over 5 squared if X is greater than 25. The membership function of the fuzzy set Y is illustrated in this figure. If one's age is less than or equal to 25, then his or her degree of membership in the fuzzy set young is 1. He or she is 100% young. If one's age is greater than 25, then the degree of membership decreases rapidly. Another example, example 2. In this example, we will consider the word old in the context old people. Let O be the fuzzy set old, and its membership function is defined as follows. The degree of membership of X in O equals 0 if X is greater than or equal to 0 and less than or equal to 50. And the degree of membership of X in O equals the reciprocal of the quantity 1 plus X minus 50 over 5 to the negative 2 if X is greater than 50. The membership function of the fuzzy set O is illustrated in this figure. If one's age is less than or equal to 50, then his or her degree of membership in the fuzzy set old is 0. He or she is 0% old. If one's age is greater than 50, then the degree of membership increases rapidly. In this lecture, we have talked about crisp sets and their characteristic functions, fuzzy sets and their membership functions. Next time, we are going to talk about notations for fuzzy sets. Thank you.